Hey everyone! So in this video I'd like to go over some problems from written homework 3. So this first example says a plumber has 3 pieces of pipe and the first pipe is X inches long. So X represents the length of the first pipe. And then here we're told that the second pipe is 5 inches shorter than the first piece, the first pipe, and then the third pipe is 9 inches longer than twice the length of the first pipe. So here we have some information about the second piece and the third piece, but it's in terms of the length of the first piece. Okay, so here we're tasked with writing expressions for the lengths of the second and third pipes. So here, this second pipe is 5 inches shorter than the first pipe. Right, so here, let's pretend, right? So sometimes it's hard to do things when there's variables involved. Let's pretend that we know the length of the piece, the first pipe, right? So let's pretend or imagine the first pipe is 8 inches long. I think this will just help us build an expression, know how to build an expression for the length of the second pipe. So if the first pipe is 8 inches long, what would you say the second pipe's length is? Well, it says the second pipe is 5 inches shorter than the first piece. Well, what would 5 inches shorter than 8 inches be? Well, that would be, right, the second piece. If the first piece was 8 inches would be, well, 8 minus 5 is equal to 3. The second piece would be 3 inches long, right? 5 inches shorter than the first piece. Well, here, we're not told that the first piece is 8 inches long. We're told that the first piece is X inches long. Right, and so really an expression for the second piece, it's no different. Instead of 8, we have X, right? This unknown number. We're saying that we have X, take away 5 inches. 5 inches shorter than X is the length of the second piece of pipe. If the first piece is X, the length of the second piece is the expression X minus 5. Whatever number X is, take 5 away from it, that's the length of the second piece. This is an expression for the second piece. Now what about the third piece? It says it's 9 inches longer than twice the length of the first pipe. Okay, well, 9 inches longer, maybe let's continue with this example again. We're thinking of the first pipe as being 8 inches long. Well, the third piece says it's 9 inches longer, so 9 inches added on to something. But 9 inches longer than what? Well, it says 9 inches longer than twice the length of the first pipe. So 9 inches longer than 9 plus twice the length of the first pipe. So we're adding 9 on to twice the length of the first pipe. Well, what's 9 plus, or how do I express twice the length of the first pipe? Well, let's express as 2 times, right? Multiplying something by 2 is doubling it, or taking twice of something. So twice the length of the first pipe is 2 times that length, 2 times X. And we're adding that on with 9. Right, and what if the first pipe was 8 inches long? What would that mean? That would mean that, well, the third pipe would be, well, twice that length, 16, and then added on with 9, it would make it 25 inches long for that third piece. But anyways, again, we don't know the value, the length of the first pipe. We're just I'm just giving a small example in the case where it's 8 inches, just to see how the other pieces would be, or the length of the other pieces would be. Just for a concrete example without variables involved. But here, we don't know the length of the first pipe. So we just have to say that it's 9 plus 2 times X. So here, that answers part A, right? Part A says, write expressions for the lengths of the second and third pipes. And so we have those, X minus 5 and 9 plus 2X. Now it says, simplify an expression for the total length, for the total length of all 3 pieces added together. Well, here, what we would have to do is we would have to add the length of the first pipe. We'd add that on with the length of the second pipe. And then we would add that on with the length of the third. And again, we don't know the exact values of the lengths, but we have expressions for how we could compute the values of these lengths, right? So here, we were told that x is the length of the first pipe. X minus 5 is the length of the second pipe. And then lastly, 9 plus 2x is the length of the third pipe. Right? These really are representing the values of their measurements, the measurements of each pipe length. And then how do we add these three expressions together? Well, we just have to combine like terms. And which terms are like terms? Well, terms with the same variable factors are like terms. So here, x, and 2x, these are like terms. And here, minus 5 and 9 are like terms. And so now we just have to combine the like terms. And to do that, we add the coefficients of the like terms. So this is like 1x, this is like 1x, and then we've got 2x. So adding those all together, this is the same as 4 times x. And then minus 5 plus 9, well, that comes out to be plus 4. And so this is an expression. What does this expression say? It tells us the length of all three pipes added together. If we know the length of the first pipe, x, we know the length of all the pipes added together, and it's given by this expression. This tells us how we can compute it without having to rebuild each one individually every time. Okay, and so one thing I want to emphasize in this problem is that we're not asked to build an equation or anything. We're not asked to solve an equation. Notice we didn't do anything like adding or subtracting the same quantity to both sides of an equation. Here we're just writing expressions for each piece of the pipe, and we're told to add them together to find the total length, right? Simplifying expression for the total length of all three pieces. So that's all three pieces added together, and that's it. Simplify the expression. And so here, that's how we ended up with 4x plus 4. Okay, so the next problem says solve some equations. So we're asked to, here maybe I'll just rewrite this equation down below. 9m minus 21 minus 7m is equal to 29 plus m minus 5. So we want to solve this equation. And so how do we solve this equation? Well, you know, we have these parts of the expression that are trapped behind these parentheses. And if we want to solve this equation, we want to isolate our variable, our unknown value, on one side of the equation, and just have all of the quantities on the other side of the equation. And so here, you know, if I'm going to have 9m and I'm going to subtract away this group here, this is the same as writing 9m. Well, it's going to subtract away everything in that group. It's going to be subtracting 21 and then subtracting away minus 7m. Well, that's the same as adding 7m. And then here, if I'm going to add on m minus 5, well, this is really just the same thing as adding on m and subtracting away 5. So here, we're just getting rid of the parentheses here so that we can really work with our m variable to get it alone on one side of the equation. And so we can simplify these expressions a little bit more, the expression on the left and the expression on the right, by again combining like terms, right? So here 9m and 7m, these are like terms, and they can be added together. They have the same variable, m. They can be added together to get 16m minus 21. That minus 21 doesn't really interact with the 9m or the 7m whatsoever. And then on the right, we have 29. Here we've got 29 and minus 5 are like terms to give us 24 plus m. And now how do we get that variable alone on one side of the equation? Well, here, I'm going to subtract away m from both sides of this equation. Right? So here, if I subtract away m, from the right, And if I subtract away m from the left, well, here what we end up with is 15m minus 21 is equal to now just 24, right? So now all of our m variables are alone, or not alone, but on one side of the equation. Next, we can add 21 to both sides to get that m variable closer to being alone, giving us 21 plus 24 is 45. And then lastly, we have m multiplied with 15. Let's divide m by 15, or let's divide both sides by 15 to get m is equal to 3. So this is the solution to our equation. This is the value that makes both of our, or makes both expressions produce the same result. Both sides of the equation produce the same value. Okay, so that's solving our equation here. The next part says solve the inequality. 4 minus 3x is less than 8 minus 2x. So here we've got the inequality 4 minus 3x is less than 8 minus 2x. And there's a few different ways we can do this. We can move around terms, we can add terms to both sides of the equation, the same term to both sides of the equation, and we can add whichever terms we want to both sides of the equation. Maybe some ways might be easier than others. I think it might be beneficial for us to, let's see, how should I do this? Let's add 2x to both sides of this equation. I want to get my x variable alone, just like we would for solving an equation. We want to get our x variable alone on one side of this inequality, so I'm going to add 2x to both sides to get rid of the x's on the right side of this inequality. And we end up with 4 minus x, right? So negative 3x plus 2x, well, that just ends up with minus 1x. And then we've got 8, and then 8 minus 2x plus 2x, well, adding 2x and subtracting 2x, those undo each other. And then next, I would subtract away 4 from both sides. This will give us negative x is less than negative, no, not negative, 8 minus 4 is just 4. And then lastly, we don't want negative x, we just want x itself. Right, so this is kind of like, this is a lot like saying negative 1 times x is less than 4. And so we can undo this multiplication by negative 1 by, actually we can multiply negative 1 to both sides of this equation. Right, because negative 1 times negative 1 is just positive 1, and then we'll just have one copy of x. And so this gives us x is, well, here we've got on the right side, we've got negative 4. And when we multiply or divide both sides of an inequality by a negative number, we have to reverse that inequality sign. So values of x that are greater than negative 4, these are the values that make our inequality true. So these are the solutions. So numbers like 5, 10, 100, negative 2, these are all values that would make our original inequality true. That's what we've found here. Okay, so let's do the last problem now. So the last problem says, consider the equation 3x minus 2y is equal to 12. And so we want to find the x and y intercepts, and we want to graph the equation here that we're given using our intercepts, and then we want to find a third solution to the equation. And we want to plot this point to verify that our graph is correct. Okay, so here I don't have a grid pulled up right away. But let me rewrite the equation. So 3x minus 2y is equal to 12. 3x minus 2y is equal to 12. So here we're asked to find the x and y intercepts, right? So what are the x and y intercepts? Well, here, if we have some curve, and we've been thinking about lines lately, if we have some line, maybe I'll just draw an example. This isn't an example of the graph of our equation quite yet. We haven't figured that out. We'll get there. But if we have like a line, for example, this line usually crosses these two axes, and these are what we call the x-intercepts and the y-intercepts. And this graph here, this is a picture of all the solutions, the pairs of numbers, all these points on this line, they're pairs of numbers that make the equation true when we plug them in for x and y. And the y-intercept, this is specifically the point that makes this equation true when x is 0. This is a solution when x is equal to 0. This is the solution of the equation when x is equal to 0. So here, we don't know the y value, but we know that this point, its position corresponding to the x-axis is that x is equal to 0. So every time you're looking for a y-intercept, you're looking for a point with an x value of 0. Now what about x-intercepts? Well, here, x-intercepts, if we look at this point on the graph, the only thing we know about it is it's a solution to the equation. It's a point on the graph, so it's a solution to the equation. And if I look at its point positioned in relationship to the y-axis, well, it's got a y value of 0. Every point on this line, or on this axis, has a y value of 0. And so every time you're looking for an x-intercept, you're looking for a solution when y is equal to 0. So here, let's do that. Let's find these solutions to our equation when x is 0, and then let's find the other one when y is 0. So here, for the y-intercept, I'm going to set x to be 0. Got 3 times 0 minus 2 times y is equal to 12. Well, 3 times 0 is 0. We've got minus 2y is equal to 12. And so we would solve this equation by getting y completely alone. Dividing both sides by negative 2 gives us y is equal to negative 6. And this is specifically when x is equal to 0. This is a solution to the equation. 0 for x, negative 6 for y. And so here, our y-intercept is the point 0, negative 6. Now what about the x-intercept? Well, we're going to do the same thing, but we're going to replace x with 0. Oh no, we already did x with 0. The x-intercept is the solution when y is 0. So here we have 3 times x minus 2 times y, but here we're looking at a y value of 0. If we're looking at the x-intercept, is equal to 12. And well, 2 times 0 is just 0, so we have 3x is equal to 12. And to get x alone, we would divide both sides by 3 to get x is equal to 4. And this, again, specifically when we set y equal to 0. That's what it means to find an x-intercept. And so we're looking at the point 4, 0. This is a solution to, this is one of the solutions, one of the infinitely many solutions to our original equation, but it's specifically the solution where we have a y value of 0. And so here, just to draw a quick and rough sketch of our graph. So let's say this is 1, 2, 3, 4, 5. I'm just going to try my best to evenly space these little tick marks. 1, 2, 3, 4. It seems I keep needing to add some distance. All right, that's okay. So these are all going to be 1 unit tick marks. And so we found that the x-intercept, the point where our line crosses the x-axis, is 4, 0. 4 for x, 0 for y is a solution to the equation. And then next here we're told that the y-intercept is 0, negative 6. So here, maybe I guess I need one more tick mark. So here we've got negative 6. Maybe I'll include a little bit more. So here's the point 0, negative 6, our y-intercept. And we were dealing with the linear equation. So we've got this line, and this is a rough sketch of this this equation. I believe it was what was it? It was 3x minus 2y is equal to 12. That's a graph of our equation. And now what's another point on this line? Well, here, another point on this line that looks like the point 2 comma negative 3 is a solution to this equation based on this picture, right? Graphs are pictures of solutions to our equation. And so let's check that this point is truly another solution to our equation. It's truly a point on this graph. So I'm going to plug in negative 2 for x, no, not negative 2, positive 2 for x, and negative 3 for y. And so our equation, it's 3 times x minus 2 times y. Does this equal 12? Well, we get 6 plus 6 is equal to 12. And so this is a solution, right? So one of the last parts of this problem was find another point on, find another solution to your equation. Find a third solution of the equation and plot this point to verify that your graph is correct. So we kind of did the reverse. We found another point on our graph, and we showed that it's a solution to the equation, and really, so we've really addressed both of these ideas. You can kind of go through this problem and actually, never mind. Let me just end there. We've found a solution, 2 comma negative 3, and it's also, we see that it's a point on our graph.